Proving Triangles Congruent, and we're going to be talking about SSS and SAS, which sounds strange. This is lesson 5.3, and we are on page 7 in the notes. All right, so those are our standards, and we're going to be using side-side-side congruence criterion and side-angle-side congruence criterion for triangles to solve problems and prove relationships in geometric figures. So first we're going to talk about side-side-side. Now, you can prove two triangles congruent by showing that all 6 pairs of corresponding parts are congruent. What that means is you can show that all of the sides and all of the angles, all 3 sides and all 3 angles, are congruent to all 3 sides and all 3 angles in the other triangle, right? So if we had this guy right here, copy and paste him right down here. And him, if we were to show all the sides and all the angles, there would be 6 things. We could prove that they were exactly the same. However, side-side-side congruence says if we're able to prove that this side is equal to that side, and this side is equal to this side, and this side is equal to this side, then we know that they're congruent already, and we do not need to know the angle measures. We just know that the angles will be the same. We can say that they are congruent triangles already. Okay? So that's side-side-side congruence. So here is the postulate. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. And you guys might already know that. So you know possibly this one, 3, 4, 5. You guys know that one? That this is a right triangle because 3 squared plus 4 squared equals 5 squared. Yep. 9 plus 16 equals 25. 25 equals 25, which means we have a right triangle right there. Right triangle. So a 3, 4, 5 triangle will always make a very specific right triangle with very specific angles, actually, the same angles every single time. Okay? So as long as you have the same lengths of sides, you will get the same specific triangle. And you can try that with any kind of side lengths. I mean, not any kind of side lengths. You can't have one side length that's 112 inches, another side that's 3 inches, and another side that's 4 inches. That's not going to make a triangle. No triangle. Sad. Okay, it has to actually make a triangle. You need to be realistic. But with realistic numbers, we're going to delete those, you can always make duplicates. Doesn't matter how you flip it around or change around their triangle. So we're going to go ahead and write a proof, and you've got that down there to show how we use side-side-side. So they're giving you QRS is isosceles, which is funny because we haven't even talked about isosceles triangles yet, but hopefully you understand that term, but we'll talk about it a little bit. And to make sure you understand isosceles, they explain it with this, that QR is congruent to SR. So I'm going to go ahead and write that on there. QR is congruent to SR. RT bisects QS at point T. So here's point T. So it's bisecting. All right, and we want to prove that triangle QRT is congruent to SRT. All right, so here is the proof. So again, I'm going to mark that QR is congruent to SR. Now we know that if RT bisects QS, we know ultimately we want to get to side, side, side. Okay? Well, in this triangle right here, it's helpful to think of them as 2 separate triangles. We could even draw them separately. You could draw this one over here and draw this one over here, just so that you keep track of them. There we go, S and Q. There we go, 2 separate triangles. And then they tell us RT bisects QS. Well, when we bisect, it means cut in half, which means this is going to be equal to this. Yeah, that's super helpful too. All right. So a side proof means all of the sides need to be equal. So we just need to talk about these sides, right? Are they the same? Well, they're both the side RT. So yeah, they're the same side because they are the same thing. Okay, so now we just need to write about that. So that's what we're going to do over here. So let's make sure we got them all in there. We got QR equals SR. That's one side. And I actually like to make a little note for myself. There's my first side. Okay, now which one do we want to write about next? They're going to write about QT is congruent to ST because of the definition of bisect. Remember, whenever there's a word up here, we're going to write that the definition of bisect, we're going to define that word down in our proof. That's going to become a big deal in this MT. So whenever you see a word, expect to see defining that word down below. Sometimes you might even see like isosceles, and you might see definition of isosceles down below, okay? But since they defined it up here, you didn't have to, okay? Okay, so there's my second side. Now we need our third side, okay? TR equals TR. Oh, there it is. There's my third side. And this one, we've talked about this rule, but we have not used it yet. We finally get to use it. Reflexive. That one is that looking in the mirror one. It's where something is equal to itself, where A is equal or is congruent to A, where something is congruent to itself. Okay? And it is specifically used in scenarios like this guy right here, where TR is in both of the triangles, and you want to tell somebody that, hey, it's used in both of them. It's equal to itself because it's in both, okay? All right. Now, excitingly enough, we've got our side, so we are set. We've got all the pieces we need to be able to say through side congruence, those triangles are congruent. And our proof is done. So triangle congruence proofs are actually very straightforward, really easy. You need to decide which way they're congruent, and then you need to make sure all of the congruent statements are there. With the congruences, like you have to have 3 congruent statements that prove them out, okay? So at the end, I'm going to expect to see 4 congruents is on here. 1, 2, 3, 4. Does that make sense? I hope so. Okay. Let's go on to example 2. Now, let's see. Use side on the coordinate plane. So they give us some vertices, coordinates for 2 triangles. Are they congruent? And they want us to use side. So by using side, they have to have same lengths. Okay? Keep that in mind. Okay. So the very first thing, they say is, think about it, is the following statement true or false? If the congruent sides in one isosceles triangle have the same measure as the congruent sides in another isosceles triangle, then the triangles are congruent. That's just a brain teaser for you. Noodle on that. So if you've got this isosceles triangle and another isosceles triangle, and this is equal and this is equal, are they congruent? I don't know. Talk to your person next to you. Pause me if you need to. Okay. So first thing, go ahead and graph your triangles. Get all your points in there. Make sure they're in the right spot. Or pause me if you need to. All right. On the next spot, make a conjecture. So use your graph to make a conjecture as to whether the triangles are congruent. Sometimes you can look at it and be like, no, not congruent, moving on, okay? But this one, they kind of look like they're the same shape and size, so I think they might be. So I guess I'm gonna have to do some math. You can't just say yes, you have to actually do some math and then support my conjecture. So I'm gonna have to do some distance formula. I'm gonna have to find the length of each one of these sides, okay? So distance formula again, distance, I think I wrote that too high because it's gonna get into that decoration up there, equals my x2 minus my x1, and I put my 2's and 1's in the air, I don't know why, minus x1 squared plus my y2 minus my y1 squared. There we go. And they have done all the math there for you and shown it worked out, and they have shown you that these match and these match and these match, which means by the definition of congruent segments, they are congruent. Therefore, triangle JKL is congruent to triangle QNP by side, side, side. And you need to fill in this blank on your page. I'm about to get beat at. All right, got my color changed on the printer. Next. Okay, so I want you guys to go ahead and do this next one. Do part A, B, and C, and pause me, come back and check. Okay. So for part A, hopefully you got this graphed well. Okay, and I'm betting from part A you kind of thought, man, they don't look very congruent, but then you did the math to prove that they were not, because they had some that matched up, but that BC and that EG did not. Does that say FG? I probably would have written EG there. Interesting. Huh. Well, interesting. Okay. All right. Now, we're going to go on to side angle side. The interior angle formed by two adjacent sides of a triangle is called an included angle. So what that means, so we've got a triangle here. the angle formed by two adjacent sides. So say we've got this side here and this side here, the angle between them, that is the side between. So when we talk side angle side, this is what we were talking about. We're talking about the side here, and the angle that they make. This is side angle side, okay? So I'm going to draw another one. We might be talking about this angle down here, and this one and that one, okay? We might be talking about, ooh, pretty, okay. We would not be talking about this. This is not side angle side. Not, oh, that's not even a circle. Goodness gracious. Not side angle side. This is actually this is actually SSA, and it is not approved. Congruence theorem. We'll spend a lot more time talking about that in a few more sessions. But for now, you may only use two sides in an angle when the angle is included, okay? Only when the angle is included, okay? All right, so the side angle side congruence is when two sides and the included angle are congruent to two sides and the included angle of a second triangle. So again, that looks like, let's see, this, copy, paste, beautiful. And we're going to say this one and this one. It would look like that. This is side angle side congruence, right there. All right. Both legs of one right triangle are congruent to the legs of another right triangle. Are the triangles congruent? So let's look at that. So if we have one right triangle, oh, that's not a right triangle. And another, and they tell us they're right. And the legs, these are the legs right here. Because obviously this one out here is the hypotenuse. So we've got this equal to that one, and this one equal to this. Is that side angle side? Yes. By side angle side congruence. Because this would also be congruent because they are both 90 degrees. Absolutely. Okay, so let's go down and look at this proof. Example 3. This playground equipment shown appears to be made of congruent triangles if KL is congruent to LM and JLK, angle JLK is congruent to angle JLM. Write a 2-column proof to prove that triangle JLK is congruent to angle JLM. Hint, in your notes, they have statement and reason suggestions to the left. So, beautiful. Right off to the left in your notes, it says statements/reasons, and it gives you a whole bunch of options there that you could fill in the blanks with right now. So that's really cool. So I'm going to go down and look at this. Here's what you get to see down there. And I kind of zoomed in a little bit on that part of the playground there. So we are given, I'm going to kind of draw this out. Let's see, we've got, oh, maybe I'll grab black. Okay, and then we've got this, nope, I like that. Nope. Come on, Notability. Do what I'm thinking, not what I'm doing. Okay, we've got J, L, M, and K. And they tell me that KL is congruent to LM. And they tell me that JKL, so I'm tracing that, JKL is this one up here, is congruent to JLM, is equal to that one down there. Okay? And I need to prove that JLK is congruent to JLM. Okay, JLM. You know what's funny? Okay. Well, let's take a look at what they got for reasons here. They've gone ahead and told us that we were only given the given first. And so then we need to put in the next one, which is also our given. So if we are doing, of course, we're doing a side angle side, obviously. For this one, we know that's where we're headed. So side angle side. And our KLLM, that's one of our sides. And JLK, JLK and JLM. Yep, I wonder. They have a misprint in the book. I just found it. This is what's causing me, why I'm pausing, guys. This is supposed to be JLK. This is why this is so important to have your order correct. There we go. That's so important because it was messing me up down here. Okay. So go ahead and cross this part out up here and make that JLK. Woo! There we go. Woo! That makes me better. JLK, JLM. Much happier. Okay, and now we've got an angle there. A side and an angle. Beautiful. So we have a side and an angle. Now, if we look at this drawing up here, what else is the same? What else can we know is the same? Not can we assume. What else do we know is the same? Because it looks like these angles are the same, but we don't know that. It looks like these angles are the same. We don't know it. It looks like these sides are the same, but we don't know it. So the only thing we know for sure is that this JL is the same in both triangles. If I was to draw this triangle down here and the other triangle up here, look at that. This would be JL and this would be JL. Same sides, same lengths, okay? Okay. So that's our other one. We need to write about that. We need to say JL is congruent to JL. And that's another side. And that is our reflexive property. And now we've got side angle side. There we go. Put that down there. That was really throwing me for a loop. All right, I'm gonna have to go right to McGraw-Hill and say I found a typo. Woohoo! All right, onwards. Now you get to try one. You got this kite here. They give you that DE is equal to FE, so make sure you're writing it on there. And that EG bisects angle, DEF. It bisects an angle. That makes it an angle bisector, by the way, guys. So that's a definition of an angle bisector, okay? So if it bisects an entire DEF, then it's cut 2 angles in half. So now you've got 2 angles that are equal to each other. Okay? Now you need to prove that DEG is congruent to FEG. So I'm going to go down here. We've got all these blanks. Go ahead and fill these all in. I'm going to go ahead and pause me, take some time. Okay. I'm going to go ahead and show you the answer. Here it is. Okay, so DE equals FE. I'm going to go ahead and grab my, 1 second, sorry. This is Cruz. Copy, bring this down, paste. There we go. Just like having my picture here. Okay, so DE equals FE, that was our given, and our other given was brought in. Now, because that definition of angle bisector, because this guy came in and bisected that angle, we now have 2 new angles. We have DEG and we've got FEG, and they are equal to each other because bisect means cut in half. Okay? So that's great. So now that means we've got a side, we've got our angle, and we need one more piece of information. So we got this, we've got these, and then we've got this line right there. We've got EG. EG is equal to EG, which is our other side. We've got side angle side now. So if I were to draw that over here, there we go. We've got side angle side. And I love to draw these separately, guys. I probably would have started with this. I would have drawn the whole thing out, D, E, G over here, G, E, F over here. And I would have written out what I knew, and I would have drawn in the bisect part, and I would have drawn in all this, and I would have figured out where my congruence was, and then I would have written out this. So this is where you start. Start here. And figure out your side, your angle, and your side. Your SAS is right there. Okay? All right. Good luck. Let me know how I can help.